Naka-move on ka na ba? This is one of the common expressions that we hear from the young people of today after a failed relationship or frustration from something. And true enough, oftentimes in our lives, we come to a crossroad where we are forced to choose which road to take, what path to follow, where to start, where to end, and in what direction we are going. As we make our own destiny, we make our own trajectory. Even objects will move in a way you set them. It may be upward, downward, horizontal. What matters is there will always be a path that they follow. Good day, learners! Angeline Sumedca, your facilitator for the topic on projectile motion. At the end of the lesson, you are expected to accomplish 3 objectives. First, identify and explain the properties of projectile such as acceleration due to gravity, range, maximum height, and trajectory. Second, determine the location and velocity of a projectile at different points in its trajectory. And the third, apply the principle of independence of motion to solve projectile motion problems. Before we move further, I would like you to listen to the poem entitled The Arrow and the Song by Henry Wadsworth Longfellow.
I shot an arrow into the air. It fell to earth, I knew not where, for so swiftly it flew, the sight could not follow it in its flight. I breathed a song into the air. It fell to earth, I knew not where, for who has sight so keen and strong that it can follow the flight of song? Long, long afterward, in an oak, I found the arrow still unbroke, and the song from beginning to end I found again in the heart of a friend.
Can you trace the path of the arrow? What do we call the path of the arrow? At what point was the arrow released? Horizontal? Vertical? Or was there an angle formed from the horizontal upon release? Remember these questions? I hope this will be answered during the discussion. Before we proceed to the lesson, let us first check what you already know about projectile motion. Read and understand each question and choose the letter of the correct answer.
Direction. Read and understand each item carefully and then choose the letter of the correct answer. Number 1. An object thrown horizontally or thrown upward will always reach the ground because of the blank. Letter A, acceleration. Letter B, pull of gravity. Letter C, downward motion. And letter D, presence of inertia. And the correct answer is letter B, pull of gravity. Number 2. What is the curved path traveled by the projectile? Letter A, range. Letter B, angle. Letter C, trajectory. And letter D, projectile. And the correct answer is letter C, trajectory. Number 3. It is identified as an object that is thrown or projected upward. Letter A, range. Letter B, angle. Letter C, trajectory. And letter D, projectile. And the correct answer is letter D, projectile. Number 4. An object that is thrown upward will always reach its peak before it moves downward. What do we call that peak? Letter A, range. Letter B, certain height. Letter C, maximum height. Letter D, angle. And the correct answer is letter C, maximum height. Number 5. An object thrown directly upward is accelerated. A, only at the start. B, only as it falls. C, only when it reaches its maximum height. D, when it reaches the ground. And the correct answer is letter C, only when it reaches its maximum height. Let us pause this video so that you can continue answering the remaining items found in your module. Let us now go over the answers to the pre-assessment questions. Number 1, B. Number 2, C. Number 3, D. Number 4, C. Number 5, C. Number 6, D. Number 7, D. Number 8, D. Number 9, D. Number 10, C. Number 11, A. Number 12, B. Number 13, B. Number 14, C. And number 15, D.
Congratulations! You have successfully answered the 5 items. It's okay if you will not be able to get all correct answers. Before diving into the lesson, let's recall your previous module on the uniformly accelerated motion or UAM, which could either be horizontal or vertical in dimension. It was emphasized that vertical motion will have an acceleration of negative 9.8 meters per second squared. This acceleration due to gravity will be used. Welcome! Together, we will discover the world of projectiles. The principles of kinematics and Newton's laws of motion will help you understand the motion of objects moving in 2 dimensions. Are you ready? Let us consider 2 situations.
The first situation is when an arrow was shot horizontally. Will it still reach the oak tree? Or we have to change its trajectory? In the second situation, we have here a ball that is hit by a player so that it can reach the opposite side of court. Or, another situation similar to this would be the arrow that is being tilted a little bit upward, forming an angle with the horizontal. This time, will it still reach the oak tree? These 2 situations will give us the idea that there are two cases of projectile motion. We will now discuss this under what is it.
At this point, we will now turn our attention to various sporting activities that you have played or officiated in your MAPE classes. What is common to these activities? We'll find out.
Two cases of projectile motion. Projectile launched horizontally and a projectile launched at a certain angle with the horizontal. The projectile is the object that is moving in two dimensions and is acted upon by gravity only. And the path followed by the projectile is called trajectory. The first case of projectile motion is when an object is thrown horizontally. Without gravity, the object could have followed a straight line path. However, due to the presence of gravity, the object will follow a curved path until such time that it will reach the ground. The object is called the projectile, while the path followed is called the trajectory. Take a closer look at the diagram that is being followed by the projectile. You can see that at every point on the trajectory of the projectile, there will always be a horizontal and a vertical component. This time, we will now see how we are going to solve projectile motion problems launched horizontally. How do we solve projectile motion launched horizontally? There are several mathematical formulas to be used. Let us familiarize ourselves with these formulas. First, we have to consider the vertical motion of the object, wherein v sub iy is equal to 0. That means the initial velocity of the object is 0 since it was originally at rest. The second formula is g sub y is equal to gt squared over 2. G there refers to the gravitational force, which has a value of negative 9.8 meters per second squared, and T refers to the time. V sub y is equal to the product of the gravitational force times the time. V sub y, or the velocity of the object moving vertically, is equal to the square root of the product of 2 times the gravitational force times the vertical distance. For the horizontal motion, the initial velocity v sub ix is equal to vx. This means that the horizontal velocity of the projectile throughout the duration will not change. D sub x, or the horizontal distance traveled by the projectile, is equal to the velocity times the time. And the other term for d sub x is the range. Using the formulas that were mentioned, let us solve this sample problem. A little girl throws her jackstone ball horizontally out of the window with a velocity of 30 meters per second. If the window is 3 meters above the level ground, how far will the ball travel before it hits the ground? To understand the problem better, let us take a look at the diagram. So the little girl is there, holding her jackstone ball, and the initial velocity is 30 meters per second. That is the horizontal velocity, whereas the vertical velocity is 0 because the object was not still moving downward. The height from where the girl was to the ground is 3 meters. We are now looking for the horizontal distance traveled by the ball. To solve the problem, we will now have here the formula d sub x is equal to v sub x times t. But since time is not given, it is the variable first to be solved. To solve for the time, we are going to consider the vertical motion of the projectile. We will then use the formula d sub y is equal to v sub iyt plus gt squared over 2. But since the initial velocity is 0, we can simply have d sub y is equal to gt squared over 2 since the product of the initial velocity times the time is 0. We can now derive for the formula in solving for t. Thus, t is equal to the square root of 2 d sub y over g. And then, we will substitute the given to the formula. We have here t is equal to the square root of 2 times negative 3 meters over negative 9.8 meters per second squared. Negative 3 meters is the vertical distance. Take note that the negative sign there denotes that it is from the top going down. And the negative 9.8 meters per second squared there means that the force of gravity is downward. Therefore, t now is equal to 0.78 seconds. This refers to the time that it will take the ball to reach its maximum height. For the horizontal motion, since we have said that the initial velocity will be equal to the velocity of the moving object all throughout, then the formula there is d sub x is equal to v sub x times time. Substituting, d sub x now is equal to the initial velocity or simply the velocity of the projectile in motion, which is 30 meters per second times the time, which is 0.78 seconds. Multiplying now, we will get the distance which is equal to 23.4 meters. That is the distance the ball traveled. Let us now consider the second case of projectile motion. If I will shot the arrow, tilting it a little bit upward, will it reach the oak tree shorter duration, or it will go to another direction? Or, if the girl will hit the ball at that certain angle, will it be able to reach the other side of the court? Before moving further with the discussion, we have to consider these concepts when we are talking about the second case of projectile motion. Number 1, the force of gravity is a vertical force that does not affect the horizontal motion of the projectile. Number 2, the horizontal velocity v sub x is constant and also equal to the initial velocity v sub I x. And the third one, the object moves horizontally forward and vertically upward until it reaches the maximum height. At this point, the vertical upward velocity becomes 0 and the object gains downward velocity. The second case of projectile motion shows that the path of the projectile is parabolic in nature. The diagram shows that there is now an angle of projection that is being formed, which is denoted as theta. We also have here the maximum height that is being reached by the projectile before it will start going down. And the distance from the point of release to the point where the projectile will reach the ground is called the range, which is denoted as r. To understand better the path of the projectile motion, let us watch this video by Easy Engineering.
Suppose you're firing a cannon at some angle. The cannonball will follow a parabolic path during its flight before it reaches the ground. We will try to understand the movement of the cannonball. First is its velocity. Initially, the cannonball has initial velocity. This initial velocity can be resolved into its x direction as and y direction as. This means that the cannonball is moving upward while moving to the right. When the cannonball moves upward, the velocity in x direction is constant or the same as the value of, while the velocity along y direction is approaching to 0. When the velocity along y direction is equal to 0, the cannonball is in its maximum height from the ground. The cannonball continues its parabolic path. During its flight, the cannonball experiences a motion going downward while going to the right. This time the velocity along x direction is still constant, but the velocity along y direction is approaching to the value same as the initial velocity along y direction, but in negative value to indicate that it is going downward until the ball reaches the ground and the velocity is 0. To sum up everything, the velocity along x direction is constant and the velocity along y direction is changing with respect to its position. Initially, the velocity along y direction is when the cannonball reaches the maximum height, the velocity along y direction becomes 0, and the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction, but in negative value. This time, let us look at the acceleration. There is no other acceleration governing to this kind of motion, but only the acceleration due to gravity, which is equal to 9.8 meters per second squared. This acceleration is pointing downward and is constant during the cannonball's flight. Lastly, for distances, there are only two distances which we should give attention. These are the maximum height, when the cannonball's velocity along y direction is 0, and the distance traveled of the cannonball during its flight. Before we end, let me leave you with this trivia. Did you know that in projectile motion, to have a maximum distance travel of an object, it should be fired at 45-degree angle? That is all for now. I hope you learned something today. Once again, this is Easy Engineering.
To solve problems involving projectile motion case 2, we have the different formulas to be used. For the components of velocity at time t, the horizontal velocity is equal to the initial velocity cosine theta, initial velocity could be denoted as v sub o or v sub I. The vertical velocity v sub y is equal to v sub o sine theta minus g. For the position of the projectile at time t, we are going to use x is equal to the quantity initial velocity cosine theta times t. And for the vertical position, y is equal to the quantity initial velocity sine theta times t minus 1/2 gt squared. The equation of the path of the projectile motion is y is equal to the quantity tangent theta times x minus gx squared over 2 the quantity initial velocity cosine theta raised to the second power. The time of the maximum height is equal to t is equal to the initial velocity sine theta over g. For the total time of the flight, it will be twice the maximum time the ball reached its maximum height. And for the maximum height of the projectile, we have here h is equal to the quantity initial velocity sine theta raised to the second power over 2g. For the horizontal range of the projectile, r is equal to initial velocity raised to the second power sine twice theta over g. And finally, for the maximum horizontal range, which is theta is equal to 45 degrees, r is equal to initial velocity squared over g. This will be your tools in solving projectile motion case 2 problems. Are you ready? You may now apply the different formulas that you have learned to solve this problem. A golf ball was hit and projected at an angle of 60 degrees with the horizontal. If the initial velocity of the ball was 50 meters per second, neglecting air friction, calculate the following. Letter A, the golf ball was in the air. Letter B, horizontal distance the ball traveled. And letter C, maximum height the ball reached. To understand the problem better, again, let us take a look at the illustration. So we have here the golf player who hit the ball with an initial velocity of 50 meters per second and an angle of projection which is 60 degrees. We are now looking for the range or the horizontal distance traveled by the golf ball, the time that it took the golf ball to travel before it finally reached the ground, and then the maximum height reached by the golf ball. So those are the three problems that we are looking for in the problem. To solve the problem, consider the upward vertical motion of the ball at maximum height. The velocity of the ball at its maximum height is 0. Therefore, to solve for the initial velocity, we have here VIY is equal to VI sine theta. Substituting the given in the problem, the initial velocity is 50 meters per second times sine 60 degrees. Therefore, the initial upward velocity is 43.3 meters per second. Solving for the time, we will substitute the given to the formula v sub y is equal to the initial velocity plus gt. V sub y at maximum height is 0, which is now equal to the initial velocity that we have just solved is 43.3 meters per second plus the value of the gravitational force, which is negative 9.8 meters per second squared, times the time in going up, or the time that it will take the ball to reach its maximum height. Solving further, t will then be equal to 4.42 seconds. This is the time that it will take the golf ball to reach its maximum height. But since we have said that the total time for the ball to be in the air is twice that of the time that it took the ball to reach its maximum height, so 4.42 seconds times 2 will now give us the total time, which is 8.84 seconds. This is now the time the ball was in the air. To solve for the horizontal distance, we are now going to consider the horizontal motion. And since we have said that the initial velocity of the horizontal motion of the object will remain unchanged, thus the initial velocity is equal to the velocity all throughout the travel. V sub ix then is equal to V sub I cosine theta. Substituting the given, we now have here 50 meters per second, which is the velocity cosine 60 degrees. That will now give us the velocity, which is 25 meters per second. To solve for the distance, we have here velocity times the time. So therefore, 25 meters per second times 8.84 seconds will now give us 221 meters, which is the horizontal distance or the range the ball traveled. And for the last problem, we are now going to take a look into the maximum height reached by the ball using the formula d sub y is equal to v sub y plus v sub iy raised to the second power all over 2g. Substituting the given, we have here 0 meters per second, which is the velocity at its maximum height, plus negative 43.3 meters per second raised to the second power, which is the initial velocity of the golf ball, all over 2 times negative 9.8 meters per second squared. I repeat, the negative signs indicate direction, which is then equal to 95.66 meters. That is the maximum height which the ball has reached. Were you able to follow the solution to the problem? If yes, then I think you are now ready to solve projectile motion problems.
Now, let us see if you can remember the terms that you have encountered during the discussion. The first activity is fix the word. Unscramble the letters to form the words that are being described in the second column. Write your answer on the space provided after the number.
Number 1. The path followed by a projectile flying for an object moving under the action of a given force? The right word is trajectory. Did you get that? Very good. Let's proceed to the next number. Number 2. The ratio of the side adjacent to an acute angle of a right triangle to the hypotenuse. And the right word is cosine. Number 3. An object propelled through the air. And the answer is projectile. Number 4. The force that attracts a body toward the center of the earth. And the answer is gravity. Number 5. It is a curve formed by the intersection of a cone with a plane parallel to its side. And the correct word is parabola. Let us now try to find out how many correct words were you able to form in the first activity. Number 1, trajectory. Number 2, cosine. Number 3, projectile. Number 4, gravity. Number 5, parabola. Number 6, curve. Number 7, inertia. Number 8, range. Number 9, angle. And number 10, sine.
Were you able to get the words correctly? Right, Ka! You are now ready for assessment 1. Complete me and the succeeding activities under what's more. Let us summarize what you have learned by completing the statements given. Write the correct word on the space provided.
Number 1. In the absence of gravity, an object in motion would continue to be in motion at a constant speed in the same direction if there is no blank force. And the correct answer is gravitational. Number 2, blank accelerates objects downward but is unable to affect the horizontal motion of a projectile. The answer is unbalanced forces. Number 3. Once the projectile reaches the blank height, it temporarily stops and moves downward due to the acceleration of gravity. The correct answer is maximum. Number 4. The blank velocity of the projectile that is launched horizontally is equal to 0. The correct term there is vertical. And for the last question, the distance is measured from the point of release of the object to the point where the object reaches the ground. The other term for distance is blank. And the correct answer is range.
Did you get it? Well done. If not, you can always go back to the discussion portion on projectile motion.
In the diagram, Two different possible trajectories are shown for a ball thrown by a center fielder to home plate in a baseball game. Which of the two trajectories will result to a longer time for the ball to reach home plate? Why? Justify your answer using the concept on projectile motion. Which trajectory did you choose? Let's try to see if your answer is correct. The one with the higher trajectory will result in a longer time for the ball to reach home plate because it reaches a higher point than the other trajectory. Thus, if the team on field doesn't want the opponent to score, the center fielder should throw the ball following a lower trajectory.
So far, so good. You were able to reach this point. It is high time for you to apply what you have learned to real-life situations. I hope you can now see the application of this topic to what is happening in our daily lives and that they are not purely technical. If you can solve the problem, very good. You can now share this to our coaches, Sir Elvis and Sir Senchu. This might help Sagada District reclaim its lost glory in the field of softball and baseball. Before answering the post-assessment, let us first look at the instructions. Choose the letter of the correct answer and place the answers in your notebook.
Number 1. Which of the following is not considered a projectile motion problem? Letter A. A football rolling down a hill. Letter B. A baseball thrown from the right field to second base. Letter C. A cannonball shot towards a boulder on the other mountain. Letter D. A volleyball served by one of the players in the red team. Go. And the correct answer is letter A. A football rolling down a hill. Number 2. Projectiles follow a blank path. A. Hyperbolic. B. Three-dimensional. C. Parabola. D. Vertical. Go. And the correct answer is letter C. Parabola. Number 3. A bullet is fired at an angle of 45 degrees. Neglecting air resistance, what is the direction of the acceleration during the flight of the bullet? Letter A. Upward. Letter B. Downward. Letter C. Dependent on initial velocity. Letter D. At 45-degree angle. Go. And the correct answer is letter B. Downward. Number 4. A golfer drives her golf ball from the tee down the fairway in a high arcing shot. When the ball is at its highest point of its flight, A. The velocity and acceleration are both zero. B. The x velocity and the y velocity is zero. C. The x velocity is non-zero but the y velocity is 0. D. The velocity is non-zero but the acceleration is 0. Go! And the correct answer is letter C. The x velocity is non-zero, but the y velocity is 0. Number 5. A bullet is fired horizontally from a gun. At the same time, a similar bullet is dropped from the same height. The fired bullet will A. Hit the ground first, then the dropped bullet. B. Hit the ground not as fast as the dropped bullet. C. Hit the ground at the same time with the fired dropped bullet. D. Never hit the ground. And the correct answer is letter C. Hit the ground at the same time with a fired dropped bullet. Let us pause this video for you to answer the remaining questions which are found in your module. Now that you are done answering, let us go over the correct answers. Number 1, A. Number 2, C. Number 3, B. Number 4, C. Number 5, C. Number 6, D. Number 7, D. Number 8, B. Number 9, B. Number 10, C. Number 11, C. Number 12, A. Number 13, C. Number 14, C. And number 15, A. How's your score in the post-assessment? I hope you did better as compared to the pre-assessment. It is always nice to go over the questions and use the discussion portion of your module as your reference. One additional activity will check further your level of understanding on projectile motion. The activity is entitled The Jumper. The diagram shows an athlete at different positions during a long jump. During the flight, the athlete is the projectile. She moves up in the air, moves down, as well as across. Study carefully the diagram and follow the direction. Let us now start. Number 1. Mark on the diagram the position where the athlete's final velocity. For this, you are going to use letter F. Number 2. Indicate the initial velocity of the athlete by marking. Use letter I. Number 3. Mark on the diagram the position where the athlete's vertical velocity is least. Use letter L. Number 4. Indicate the zero velocity of the athlete by marking on the diagram. Use letter M. And for the last question, number 5, what happens to an athlete's horizontal velocity during the jump? Let us now go over the answers of the additional activity. Number 1, F is at point 6. Number 2, I is at point 1. Number 3, L is at point 3. Number 4, M is at point 3. And for number 5, the athlete's horizontal velocity will not change. It will remain constant during the jump. How many of you got all the correct answers? If you got all the correct answers, that means that you have understood the lesson on projectile motion. Thank you.
Congratulations for making it till the end. Was the trajectory tough enough for you? But no matter what, you made it through. See you again in your last 3 modules. And finally, the school year is over. Stay safe,